This video will continue to discuss linear relationships. Specifically, we're going to look at how to find the slope for a linear relationship. Recall that a linear relationship is any relationship between two variables that forms a straight line when graphed on a coordinate plane. We see three examples here in red, blue, and green of different linear relationships. They all form straight lines on the graph. When we talk about slope, we're referring to the unit rate of change for a linear relationship. This unit rate of change is always written in the form change in y over change in x. We're going to often use the letter m as a variable to refer to slope. The straight line formed by every linear relationship tells us that x and y follow some repeated pattern. In other words, all straight line graphs must have a constant rate of change. Slope is a measurement of that constant rate of change. In order to find slope for a linear relationship, we need to use at least two data points to determine the rate of change between y and x. We're going to look at the green linear relationship as an example of how to find slope. Here we see the green linear relationship, and we've picked out three data points in purple, red, and blue. We're first going to look at if we traveled on the green line from the red dot to the blue dot, how would we get there? We would need to travel right by 6 units, or x would increase by 6, and we would need to travel down by 4 units, which means that y would decrease by 4 units, or negative 4. We see up here change in y could be written as negative 4, change in x could be written as 6 if we traveled from the red dot to the blue dot. If we traveled from the purple data point to the red data point, we would need to travel right by 3 units, or x would increase by 3, as y decreases by 2 units, or we travel down by 2. In the form y change over x change, we would write this as negative 2 over 3. That's an equivalent fraction. It has the same value as negative 4 over 6. If we tried to simplify these fractions or do the division, we would get to an answer of negative 2/3, or as a decimal, negative 0.67. Recall that this slope is telling us the unit rate of change, how much y is going to change by each time x increases by 1 unit. In this case, y is going to decrease by 0.67 units, or 2/3, every time x increases by 1 unit. This is the same as rate as y decreasing by 2 units every time x increases by 3 units, and we would encourage you to leave slope as a fraction or a ratio instead of converting it into a decimal.